Imagine you're in a bustling industrial setup, where precision and efficiency are paramount. You're tasked with printing critical data from an OMRON CQM1 PLC, a cornerstone in industrial automation. This isn't just about pushing a button, it's about understanding the intricate dance between hardware and software. The challenge lies in the serial communication between the PLC and a printer, a process that demands meticulous configuration and a deep understanding of the PLC's capabilities. We're diving into the heart of this challenge, exploring the mechanisms, parameters, and nuances that make this possible. And here's why that matters. Mastering this process not only enhances your automation skills but also ensures seamless data flow in your industrial operations. Imagine you're sending a letter through a single-lane tunnel. This is akin to serial communication, where data is transmitted one bit at a time. Unlike parallel communication, which sends multiple bits simultaneously, serial communication ensures data integrity over long distances. The key parameters here are baud rate, which dictates the speed of data transmission, and parity bit, which helps in error checking. For instance, a baud rate of 9600 means 9600 bits per second. The parity bit can be even, odd, or none, depending on your system's requirements. Understanding these basics is crucial because they form the foundation of how your PLC and touch panel to configure the OMRON CQM1 PLC for serial printing, you need to follow a precise sequence of steps. Begin by connecting your programming cable to the PLC's programming port. Use Syswin or CX Programmer to interface with the PLC. Set the communication parameters on the serial port to match your printer's requirements. This includes baud rate, data bits, parity, and stop bits. For the CQM1, utilize the TXD and RXD instructions for transmitting and receiving data. Remember, TXD reads data from specified words, converts it to ASCII, and sends it out. RXD, on the other hand, reads incoming data and stores it in designated words. Ensure you're aware of the buffer limitations and flags that indicate transmission and reception statuses. This meticulous configuration Now, let's dive into the execution phase. To connect and print to the serial printer, you need to follow a precise sequence. First, ensure your PLC is configured with the correct baud rate, typically 9600, and the appropriate data bits, parity, and stop bits as per your printer specifications. Next, use the TXD instruction to transmit data from the PLC to the printer. Remember, the TXD instruction reads data from specified words and converts it to ASCII before sending it out. For receiving data, utilize the RXD instruction, which reads incoming data and stores it in designated words. It's crucial to manage the buffer size, typically 256 characters, to avoid overflow. Also, be aware that transmission occurs in 8-bit characters, while the channels are 16-bit, containing 2 characters each. For optimal performance, write your data directly in ASCII to the data memory (DM) of the PLC, ensuring it aligns with the printer's protocol. Now, let's dive into handling edge cases and optimization for serial printing. Imagine you're dealing with a high-traffic environment where data throughput is critical. One common issue is buffer overflow. To mitigate this, ensure your PLC's buffer size is set appropriately. For instance, if you're using an OMRON CQM1, set the buffer size to at least 512 bytes. This prevents data loss during high-volume transmissions. Another edge case is handling communication errors. If you encounter error code 8001, it typically indicates a loose cable or outdated driver. Always verify your connections and update drivers to the latest version. For optimization, consider using the TXD and RXD instructions efficiently. TXD reads n bytes of data from words S to S plus n/2-1, converts it to ASCII, and outputs the data. Ensure you're using the correct baud rate and data bits/parity settings as per your printer's protocol. Lastly, remember that the PLC will be incapable of receiving more data once 256 bytes have been received if not read using RXD-. Read data is